Hello and welcome to Oughton Math. In this edition of Oughton Math, we're going to continue our discussion about graphing polynomials and graphs of polynomials. In the prior lesson, we took a polynomial function, then we graphed it. In this particular video, we're going to talk about writing an equation for a polynomial based on a graph, so the other direction. Right. So let's take an example. I have a polynomial, and I'm given 1, 2, 3, 4 coordinates, and let's take care of writing an equation for this polynomial. So you see that I have 3 x-intercepts and then 1 non-x-intercept. The first thing we want to do is to identify the factors. So the factors are going to be x, x minus 1, x minus 2 for the coordinates 0, 0, 1, 0, and 2, 0. And then we want to test the non-root coordinate, so -1, -12, into the system and then solve for a value which I'll call a. And so we write a here as an unknown, and we know that a times x minus 1 times x minus 2 is equal to y in this case. And so we're going to substitute the value in for x, and then we're going to solve for y. All right, so I'm going to substitute -1 in for x, and I'm going to solve for y, and I get -6. And so we know that the value of a times this value of -6 has to be equal to -12. Right? So let's rewrite this as this function as a times, and let's write this in black, a times 1 for x times -1. Because -1 is our value for the non-root coordinate. -1 times -1 minus 1 times -1 minus 2 is going to be equal to -12. Right? So -1 here is the input, -12 is the output. So now we have to solve for a, right? And we end up in this function when we just substitute -1 in with -6. So a has to be equal to 2. So 2 times -6 is equal to -12. So we're going to write in the value of a here. 2 times x minus 1 times x minus 2 is going to be equal to y in this case. So that's how we create a polynomial function. First we find the factors, and then we test the non-root coordinate in the system, and then we're going to solve for the value of a. All right, so let's have you take a crack at solving on your own. So I'm going to give you a function here. You're going to identify the factors, test the non-root coordinate, and then adjust the value of a. I'm going to pause here, and you're going to come back. All right, so I'm going to write in my function, identify the factors with a times x plus 1 squared. So this is a double root, right, because it bounces off or is tangent to the x-axis. X plus 1 squared times x minus 1 times x minus 2 is equal to y. Then we're going to test the non-root coordinate. I'm going to substitute in my non-root coordinate is 0, -3. 0 plus 1 squared times 0 minus 1 times 0 minus 2 is equal to 2. So I end up with 2a is equal to -3. And then I'm going to solve a is equal to -3/2. All right, so when I substitute the value in, right, so 2a here is equal to -3. I substitute -3/2 in, and I'm able to solve for this value. All right, so -3/2 times x plus 1 squared times x minus 1 times x minus 2 is equal to y. All right, let's go on for another example. Let's write a polynomial equation. We're going to find the equation of a cubic function whose graph passes through the points 3, 0, 1, 4 and is tangent to the x-axis at the origin. So I'm going to pause here. All right, so I find my factors x squared, x minus 3. Now I'm going to write it with the a value because that's the unknown part of it that we need to solve for. A times x squared times x minus 3. Now I'm going to substitute that value in for the non-root coordinate 1, 4. A times 1 squared times 1 minus 3 is equal to 4. So 1, 4 is my coordinate. Now I'm going to solve for a. A times So 1 times negative 2 is negative 2. A times negative 2 is equal to 4. I'm going to divide both sides by negative 2. A ends up being equal to negative 2. And then I'm going to rewrite my function as y is equal to negative 2x squared times x minus 3. All right, that's it for this edition of Odd Math, a really quick video on writing a polynomial equation from a graph or from a description of a graph. So again, walking through the steps, we want to identify the factors, test the non-root coordinate, and solve or adjust the value of a, and then we're going to write our function. That's it for this edition of Odd Math. Come back next time when we talk about maximums and minimums and solving for quadratic and cubic functions and maximizing and minimizing values in the next edition of Odd Math.